We're going to continue on with the next property. The next property is the commutative property of addition. So the commutative property comes from the word commute, and commute means to travel. Like if I commute to school, that means I have to travel to school. And it says that the order in which we add numbers doesn't change the answer or the sum. So a plus b equals b plus a. They're the same. They are equal. An example would be 6 plus 4 equals 4 plus 6. It doesn't matter if I put the 6 first or the 4 first. At the end of the day, when I add them together, I'll still get 10. In this first example, it says, using the commutative property, rewrite the statement. If not possible, write NA or N/A. So we have 34 plus 17. If I want to rewrite that using the commutative property, that means I have to travel or change positions of these numbers. So they are going to move position. So 34 plus 17 is equal to 17 plus 34. Right? They are equivalent statements. They're equal. I'm just changing the order. 29 plus 8 is the same thing as 8 plus 29. Okay? Same numbers, just changing the order. The next one says 72 minus 56. And we go back to the property. It says the property of addition. So we have to wonder, does this property also work for subtraction? Well, let's think about this. This says 72 minus 56. If I relate it to money, so I had $72 in my pocket, and I spent or take away $56, I'd have a certain amount, right? And I'd still have some money in my pocket. If I change the order, if I try to do 56 minus 72, well, 56, if I had $56 in my pocket and I spent 72, now I've spent more money than I had, and I actually end up negative. So these two things are not equal. So I can't use the commutative property for subtraction. They end up being two different values. They're not equal. I can't use it. So we're going to write N/A. Right? In this next part, it says, use the commutative property to make the addition easier. So the whole reason that we learn the commutative property is because we're going to use this property as we move up into higher level math classes, but also because it makes our math easier for us to do mental math or to add things quickly. For example, here I have 2 plus 3 plus 7 plus 8 plus 4. Now if I went straight through left to right, I could probably add that, but it might take me a minute to add and to carry and do things like that. But if I rearrange the order, so 2 plus 8, I move the 8, it commutes, it travels over towards the 2 to make 10. That's a much nicer, easier way to add. And then I continue with 3 plus 7, there's another 10, and then I'm going to leave that 4 alone. So all I'm doing is rearranging the order of these to make my addition simpler. Because now I have 10 plus 10 plus 4, and I know it's 24. Okay, you do not always have to rewrite things. Sometimes I see students just go straight from like 8 plus 2 and then 3 plus 7 like that, and they end up with the same answer. But the reason that that works is because of this property, the commutative property. Let's try another one with 17 plus 8 plus 3 plus 5 plus 12 plus 4. Again, we're going to try to rearrange these to make our addition simpler. I'm starting with the 17, and I'm looking for multiples of 10. So if I add 3 to that, I rearrange the 8 and the 3, that's going to make 20, and that's going to be a nice, easy number. So then I continue on with the 8 plus what would be a nice, easy number. I'm going to add 12, because 8 plus 12 is 20 again, a multiple of 10. So just to keep track, I've used the 17, I've used the 3, I've used the 8, and I've used the 12. And looking at what's left, it's not going to get me to 10, so I'm just going to continue with plus 5 and plus 4. Okay, and now I'm going to add. So 17 plus 3 is 20. 8 plus 12 is also 20. Plus the 5 plus 4 is 9. So now I have 20 plus 20 is 40, plus 9 more is 49. And if you get good at this, you can rearrange them in your mind and add things up really fast instead of having to write out every step. Hope that helps.